All right, here's your notes for section 4.5. I hope you can hear me okay. If you can hear me, raise your hand. Gotcha. You're going to want to start with the side angle side theorem, SAS. We did side on Tuesday, so we're going to talk about side angle side now. And side angle side, look at your cheat sheet number 6, SAS. If two sides and the included angle, yes, I highlighted it, the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So first we're going to work with what do they mean by the included angle. It has to be the angle between or made up of the two sides. Name the included angle. First I'm going to have you draw this diagram. Just draw the triangle right now. You've got triangle ABD. It's split right in half by segment AC. Take the time to draw it, label it, pause this if you need to. We need the included angle between segment AB and segment BC. Here's the best way to figure out the included angle. Draw it. Draw segment AB, draw segment BC, and if I move the triangle out of the way, there's my angle. What angle was included or formed by those two? It's angle B. So the answer to this one is angle B. Segment AC and segment BC. Segment AC and segment BC. Where's the included angle? It's angle C, but you got to be careful. I can't call that angle C. We've talked about this before. I can't call it angle C because there's more than one angle C. To name the included angle, I need to call it angle BCA or angle ACB. Order doesn't matter as long as your vertex is in the middle. Next one. What is the included angle between segment AC and segment BA? Once again, you can see that it's the angle at the top. But I can't call it angle A because I need to decipher between the two different angles. So I'm going to call it angle BAC, or you could call it angle CAB. Either of the two, it has to be the included angle at the top. All right, you're going to take a moment to pause this and do these three. Segment AD and segment CD. Segment AD and segment CA. Segment CD and segment CA. You find the included angle. Do that now while you pause it. Okay, we're back. You should have angle D here, and that's okay to call it by itself. It's the only one there. Segment AD and segment CA make angle CAD or angle DAC. And the last one, segment CD and segment CA, would make angle ACD or angle DCA. Hopefully you got those right. If not, go back and change them. Now you know what the included angle is on side angle side. The included angle is the one between them. We are going to decide whether the congruent statement is true, or if it's true or if it's not true. We need to explain our reasoning. Go ahead and draw this. Make sure you write the congruent statement at the top. Here's your two triangles, and there's the drawings of them. Drawings and markings, please. Go ahead and draw those now. Pause it. And now that you're back, it said explain your reasoning if they are congruent. We have a side. We have an angle. And we have another side. So we are going to try to explain it by side angle side. However, it only gave us the markings of the two sides. It did not give us a congruent angle. How do we know that angle W is congruent to angle P? If two angles, they are both 42 degrees. If the measure of two angles are equal, then the angles are congruent. So if we do a tiny little proof in our head, definition of congruent says If two angles have the same measure, then they are congruent. So we can prove this by side angle side. Side, included angle, side. Next one, go ahead and take the time to draw that triangle. The two triangles with the box. Write the congruent statement underneath. Pause it here. Okay, so we're checking to see if triangle TAZ is congruent to triangle ZCT. Okay, we do know that this side is congruent to this side. We know that this angle is congruent to this angle. We're checking to see if there's a possibility that we could actually have side angle side. We don't yet. Do we have a third side, and is the angle going to be included? Yes, it looks like we have the third side by the reflexive property, but you may want to check. Does it work on both triangles? And if it helps, separate your triangles. Draw them separately. On this one, we have side, included angle, side. Up here, we have side, included angle, side. Side angle, side. Check the markings. Does the T match the Z? Yes. Does the A match the C? Yes. They're the ones that look like they're 90. Does the Z match the T? Yes, they are both marked with congruence. So therefore it is side angle side. What piece were we missing? The reflexive property. We're going to need that when we do a full proof. Last one of these. Go ahead once again, draw that figure, label it properly, and put the markings on it. Draw it, label it, markings, pause it now. Okay, this one looks a little bit more complicated. I do see a side here and an angle. We have side angle. We need a third side. Let's see if we can find a third side. Okay, I see this triangle over here on the left and this triangle over here on the right. Side, angle. We put them back together, and once again we have the reflexive property. There's your reflexive property. But watch what happens. If I move this over here, and we mark this reflexive property down here, we have side and an angle. Is that angle included between the two sides or not? If I trace the two sides, the angle that is included has to be between them. That angle is not included between them. Okay, be careful. Be careful of that in those diagrams. Same thing over here. We have an angle, we have a side, and we have another side. Ever seen that postulate before? I hope not. Don't write that on your paper. If you write a naughty word on your paper, it's wrong. Not because it's naughty, because we don't have that postulate. There's no such thing as an ASS or an SSA. So, question is, determine whether or not they are congruent. They are not congruent. We have no way of knowing that those triangles are the same. Next up, if you look at cheat sheet number 7. Cheat sheet number 7, if two lines are parallel, then corresponding angles are congruent. We learned this in chapter 3. If two lines are parallel, then alternate interior angles are congruent. If two lines are parallel, then alternate exterior angles are congruent. If two lines are parallel, then consecutive same-time interior angles are supplementary. It's the only one that's different. We've got congruent, 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 and supplementary. Be careful of that. Look for it on your cheat sheet. Notice these are not if and only if statements. It's not working forward and backwards. You have to have a parallel line, a pair of parallel lines before you can do corresponding angles. You have to have parallel lines to make alternate interior angles. The underline, bold, italicized, that's your reason on a proof. So use cheat sheet 7 for this. Go ahead, take the time, draw that diagram right now. It's asking you to name the congruent angles. Pause it here. Okay, so we're looking at naming the congruent angles. That's all they want to know is, can you name the congruent angles? I see a pair of parallel lines. If I draw these two parallel lines and this transversal, if I only draw part of it or look at part of it at a time, I've got a pair of congruent angles. right here at U and right here at Q. So I have angle Q is congruent to angle U. Those are alternate interior angles. Didn't ask us to give a reason, but you should. Okay, how about another pair? Another pair of angles. If I put this back, another pair of congruent angles. I have another pair of congruent angles right here. If I look at only the parallel lines and the transversal and not the triangles, I have angle T is congruent to angle R. And yes, it's okay to call them angle T and angle R because they're the only vertex at that angle. Those are also alternate interior angles. But believe it or not, we also have a third pair. Has nothing to do whatsoever with the parallel lines, but we still have another pair of congruent angles. And I can call that one angle QSR or RSQ is congruent to angle TSU or UST. What's the reason for those? Yep, vertical angles. Alternate interior angles, vertical angles are congruent. All right, here we go. We're going to do a proof. Go ahead, start here. Set up your proof with statements, reason. Make the given, draw the proof, draw the triangle, be ready to label it. You're going to pause it in a moment. You're going to write all this down, and you're going to try to do this one step ahead of me. Do the givens, and then ask yourself, what would I do next? Then go ahead and play the video and see, is that what I did next? Is that what she did next? Do they match? Could it work the other way? Okay, if you just watch this and copy it down, you're not learning the proof. You're not understanding. Try to walk yourself ahead of it, one step ahead of me. So you're going to pause it here, get it all set up. We're back. We've got the givens. Key word on the first given is perpendicular. If, look it up, definition of perpendicular. If two lines are perpendicular or two segments are perpendicular, DR, AG. If two segments are perpendicular, then they form a right angle. And I have to be careful that I name it angle DRA, not just angle R. Angle DRA is a right angle by definition of perpendicular. But as you will get used to and as you've seen over and over and over, when you have a full segment, you actually automatically just made two right angles. Angle DRG is a right angle, also by definition of perpendicular. What will you do with those two right angles? You should know this. We've done this. It's been in different proofs, but we've done the same step over and over and over. Check it yourself. Now check with me. Angle DRA is congruent to angle DRG. Why? Because of the right angle congruence theorem. So now we're going to go back up to our diagram and label what we know and what we need to know. We now know that angle DRA and angle DRG are congruent. So we have a pair of congruent angles. We also have a pair of congruent sides. Your pair of congruent sides, go ahead and mark it. Segment AR is congruent to segment RG. Look at how close we are. Now that we get to do shortcuts with triangles. Side, angle, side. We need another side. They didn't give us another side. We don't have another side. Go back up and look at your diagram. I need side, angle, side. Where are you going to get it from? Where are you going to get that second side from? If you did this, you got it. Segment DR is congruent to segment DR because of the reflexive property. Go up and label it. Mark it. Side, angle, side. Side, angle, side. Both triangles, each of the triangles separately, have to have their own markings. Side, angle, side. The triangle over on the right has to have its own marking of side, angle, side. You can't count this, side, angle, side. You can't jump triangles. Each triangle has to have the side, angle, side marking, which will give you the proof. Side, angle, side. Still 7 steps long, but imagine if we still had to do 3 pair of congruent sides and 3 pair of congruent angles. That would take a lot of steps. We get to shortcut it. We need a side, an angle, and a side. All right, next up, the HL theorem. That's on cheat sheet 6 as well. Cheat sheet 6, the HL theorem. Hypotenuse leg. Notice we don't even have to call it HL theorem. We're just capital H, capital L. That's what you can put on your reason. If the hypotenuse and a leg, any leg, of a right triangle are congruent to the hypotenuse and the leg of a second right triangle. They have to be right triangles. Then the 2 triangles are congruent. That is not side angle side. Side angle side would have had the angle up in between them. It's side side angle. We don't have a side side angle. It doesn't work unless it's a right triangle. You need a hypotenuse and a leg. Got to be a hypotenuse and a leg. So we're going to go from there and do one more proof. Go ahead, set up the givens, set up the triangle. You can try it. Completely try it by yourself. Go through it. Use an eraser. Write really lightly, whatever it takes. See if you can make your own proof. Check it step by step. Check it all at once. Do whatever. Pause it now. Get it set up. Okay, you're back. You should have the statement. You should have the reason. And as soon as you see something, you should mark it right away. I will not help you on your assignment if you don't have a drawing in your notebook. You have to draw this on paper so that you can mark it up. Segment WY. Segment WY is congruent to segment XZ. And if you want to trace it so that you know that it's the entire segment, those 2 are congruent to each other. And we have another perpendicular. Okay? Every single time you see a perpendicular, you're going to do the same thing. If 2 segments are perpendicular, then they form a right angle. You just have to find the right angle. Angle WZY is a right angle. Angle XYZ is a right angle. And actually, here's what I'm going to do. I'm going to label one of the triangles with blue and one of the triangles with red so we can distinguish between them. We already know that this is congruent to this because it was given. Now we know that this angle is a right angle as well as this angle over here on this triangle. If you want to draw 2 separate triangles, go for it. We have a side. We don't have any congruent angles yet. So far we only have a congruent side. But we have 2 definitions of perpendicular. If that's a right angle, so is that. 2 definitions of perpendiculars. Angle WZY, angle XYZ. And same as the previous proof, if you have 2 right angles, then those 2 right angles are congruent. Get used to that. You're going to have proofs that have perpendicular. There are 3 steps that will 99% of the time follow perpendicular. If perpendicular, then right angle. If perpendicular, then right angle. If 2 right angles, then right angles are congruent. Oops, I don't have that yet. Sorry. Back up. This time, we're going to say triangle WYZ is a right triangle. Why are we going to say that it's a right triangle? Because of the definition of right triangle. So is triangle XZY is also a right triangle by definition of right triangle. If a triangle has a right angle, then it is a right triangle. How did we know we were going to use the HL theorem? Because we don't have side, angle, side. We have our side marked in the wrong spot. So far we have a hypotenuse. The hypotenuse is labeled. We need another side. Where's our other side going to come from? Well, it says we have to have a hypotenuse and a leg. If I'm looking at this triangle, I'm going to need this leg. Why is that leg congruent to this leg? Because they are congruent to each other by reflexive property. Segment ZY is congruent to segment ZY by the reflexive property. One of them was from the left, the red triangle. The other one was from over on the right, the blue triangle. We don't have congruent, congruent, congruent. We have a side and another side. We don't have congruent angles, but we know that it's a right triangle. Therefore, we finish with the proof by the hypotenuse leg. Check and see, hypotenuse leg. We have a hypotenuse, WY, and a leg, ZY. Segment WY, segment ZY. Go back, look these over. Make sure that you understand them. It doesn't do you any good to just copy these notes. Quick, get it over with. I'm finished, I'm done. Okay, and now I can do my assignment. Go back and look through them. Don't do them too fast. I did them much faster here than I would in front of a class because I would take the time. Pause it as much as you need. Once this is finished, you get to check it with me and start your assignment as long as your notes are complete. All right, that's the end. Shut her down and good luck.